All right, so the next quadrilateral we're going to talk about is a trapezoid, and a trapezoid is not a parallelogram because both sets of opposite sides are not parallel. In a trapezoid, only one set of opposite sides has to be parallel, and these sides are called the bases. And I know that's a little weird because we have two bases, a top and a bottom. And usually you think about the base as the bottom, but this one is also a base. The other two sides are called legs. Just like in the right triangle, the legs were on either side of the right angle. We have legs in a trapezoid that connect the bases. We can have an isosceles trapezoid if the two legs are congruent. So if those legs are congruent, it's isosceles. So we're going to think about an isosceles trapezoid, and all the things about isosceles triangles are going to come into play with isosceles trapezoids. We know that in an isosceles triangle, the base angles are congruent. Well, the same thing is true in our isosceles trapezoid. The base angles are congruent. So in this case, these two angles are congruent. Since there are two bases, the pair at the top are also congruent. We do not know that these are congruent to each other, but what do you know about the consecutive angles in a quadrilateral? The consecutive angles in a quadrilateral are supplementary. So if you know that this one is 80 degrees, then this one is 100. And if we know this one is 80, this one is 100. Well, but that doesn't work as far as our adjacent angles go, do they, huh? So hold on that thought. We might not be right there. Diagonals are congruent in an isosceles trapezoid. So that means that this line segment and this line segment are going to be congruent. All right, something new from a triangle. We had talked about a median of a triangle being the piece that connects the two sides that connects two sides at their midpoints, so that would make these two congruent and these two congruent. If this side, this segment happens to be parallel to the base of the triangle, then it's considered a mid-segment. And the mid-segment joins the midpoints of two sides of the triangle, is parallel to the third one. Something cool about the mid-segment is we can figure out its length because this is always half of the third side. So that means that if AC is 12 and I want to find the mid-segment, all I have to do is think what's half of 12, and since I know it's 6, I've got my answer. Sometimes they'll give you an algebraic expression and say, okay, well, if this is 4x, then how long is the mid-segment? Well, since the mid-segment is half of the third side, what's half of 4? 2, so my mid-segment is 2x.